Good morning. So yesterday we have done with the 31 questions, I think. So we are continuing with the 32nd question. So still if you have any doubts among those 31, you can post it. And someone was telling some 17th, 18th, 19th is missed. So we'll cover that also once again today. Okay. So 32nd question. The photoelectric threshold wavelength of silver is 3250 into 10 to the power of minus 10 meter. The velocity of ejected electron ejected from a silver surface by ultraviolet light of this much wavelength is, so data is there again, that is not necessary for us. So we need to calculate is velocity of the ejected electrons. Okay, if suppose threshold frequency, threshold wavelength is this and incident wavelength is this is there. Okay, so a direct question is that we know that kinetic energy, maximum kinetic energy will be equal to, we are having hc by lambda minus hc by lambda naught. Okay, minus work function. So therefore velocity maximum square, this becomes equal to 2 times, I can take hc common, divided by m into 1 by lambda minus 1 by lambda naught. And you be clear, usually the datas will be designed. So instead of getting scared seeing the datas, okay, because here it is taking maybe much time for calculation. But you not worry, always the datas will be designed. So 6.6 into 10 to the power of minus 34 I can take. If you want, you can use the given data. Into 3 into 10 to the power of 8 divided by mass of electron 9.1 into 10 to the power of minus 31 is there. Whereas the wavelength you can fill, and even wavelength, this power you can take outside, 10 to the power of minus 10. 1 divided by incident is 2536 minus 1 divided by the threshold wavelength, that is 3250. Just simplify all this and verify if suppose your answer is differing. So message in your WhatsApp group. So the option given is the first one. Okay. Well, 32nd is the first option. So you are going to get nearly 0.6 into 10 to the power of 6 Miss VM, I am saying it's a square. Okay, meters per second. Fine. So the next question we are having is photons with energy 5 electron volt are incident. Okay, I think some of you have calculated already. So Abhi is telling A option. Yes, sir, correct. Okay. Photon with energy 5 electron volt are incident on a cathode C, that is electrode, what we call as emitter electrode. So 5 electron volt. In a photoelectric cell, you know that it's the application of your photoelectric effect, what you use in your many appliances, photoelectric cell, so which will work out with electromagnetic radiations. Okay, on the photoelectric effect concept principle. The maximum energy of emitted electrons they found as 2 electron volt. So these two data gives you what? Energy is this much. Then what will be the work function you can calculate as? It becomes incident energy minus the kinetic energy. So that gives you 5 minus 2 means you are having it as 3 electron volt is work function of that particular material. Okay. Whereas the photons of energy 6 electron volt are incident on it. No photoelectrons will reach. No photoelectrons will reach means what? Ultimately, that says what applied potential is nothing but the stopping potential you are going to have. So, Question is, so ultimately what is the stopping potential? You'll calculate in the second case as EVS should be equal to the new kinetic energy. What will be new kinetic energy? 6 minus 3, because this is not going to vary. Yes, many of you are answering already. Shreyas, Satvik, Mallesh, good. Okay. So this is not going to change. Work function not going to change. This time incident is 6 electron volt minus 3 electron volt. So this became how much? 3 electron volt. Then ultimately stopping potential is how much? 3 volt. But be careful. If they ask you only stopping potential or how much is the potential difference to be applied required, then you'll go with the positive values. But because we want only magnitude, even yesterday in one of the question I was telling you. But here the question is with little condition. That is, if the stopping potential of A relative to C. When you take A relative to C, this is your emitter, cathode, okay? So whereas this is your collector, anode. So this relative to this you are applying is what? Negative potential. So ultimately, so we have to go with minus 3, okay? So we have to go with the last option. Hope it's clear. When they give this particular condition relative to cathode, you have to answer, because we know that we apply negative potential to stop the upcoming electrons, moving electrons towards the collector electrode. Otherwise, you have to go with only magnitude, okay? So be careful. Well, so 34th question. An electron of mass m and a photon have the same energy. So they are given electron and photon. So this is not proton. Take care, it's a photon. Okay. And we are having electron. So what is given? Electron energy is equal to, we are having photon energy. The ratio of de Broglie wavelengths associated with them is. So what is de Broglie wavelength? Of electron by photon, they are asking. So this equation we know. With matter waves, we have the formula as what? We have the formula as h by the m into v. Or in terms of energy they are asking. So we can have it as square root of 2, I'll write here once again. H by square root of 2m I can have. Divided by, this is what? So energy of the photon is given by what? Energy of the photon when you take, so even this, but we are working for wavelength. So what is the wavelength? We can write as E divided H, okay, lambda equal to, we can write as what? We can write as H by P itself. But momentum of the photon will give it as what? Momentum of the photon, hope you remember, you have it as E by C there. Okay, E by C is there. So accordingly, but they are not asking in terms of that. I think H by okay, C is there in the option, no problem. I was thinking that where C has to go. Okay, no problem. So we can fill here. So ultimately here I can write as H by in place of P. So in place of P, I'll write as what? E by C. So E by C will be there. So that becomes HC. Okay, so H and H will get cancelled here. H and H will get cancelled. So it will come to the E divided by C square root of 2m E you are having. And again 1 E will get cancelled, it will become root. Hence you are going to get is 1 by C. Then, so since they are again the form of the power, so root itself we can write like that. E divided by 2m to the power of 1 by 2. Yes. Well, so all of you answered. Very good. So C is the correct option. Okay. Well. So next question. So happy to see that many of you have worked out and kept already. So it's worth then, okay, posting the paper in advance. Okay, so we'll do the same thing because so that you can enjoy the paper after understanding synopsis also. When a metallic surface is illuminated with radiation of wavelength lambda, the stopping potential is found to be V. If the same surface is illuminated with radiation of wavelength 2 lambda, the stopping potential is found to be V by 4, the threshold wavelength for the metallic surfaces. See, just you have tried two statements here. First statement is Hc by lambda because lambda is incident. So Hc by lambda naught plus, since stopping potential is E, we'll write as what? EVS, I'll write as now EV. Whereas in the second case, yes, Sharon got, okay, 3 lambda, let us check it. So E into stopping potential. Second case, what will you write? So second case, they again it as 2 lambda. So ultimately it becomes Hc by 2 lambda will be equal to Hc by lambda naught plus E into, we are having V by 4. But since your options are in terms of only lambda, okay, so hence we go with the what? We eliminate this. Okay, since we don't want this, we'll eliminate. What is EV is from here? You can just simply substitute. It becomes Hc by 2 lambda will be equal to Hc by lambda naught plus, for EV it becomes Hc by lambda by 4 because by 4 is there, minus this, minus lambda, this should be by 4 should be there, and minus this, so minus Hc by 4 lambda naught. So if I just take this one, this side, and simplify all these things because Hc will anyway get cancelled. So take lambda one side and lambda naught one side. So if you simplify, you are going to get is the second option. Okay. Well, Santosh Jadira, I think. Satvik, Rajshekhar, yes, Sharan Gowda, all of you are correct. Okay. So second option is correct. It's 3 lambda. So next question. A photoelectric surface is illuminated successively by monochromatic light of wavelength lambda and lambda by 2. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that in the first case, the work function of the surface of the material is. So it's a similar question what we did in the previous question, okay, like previous, okay. See, just again you have tried two statements. There it was with potential, here it's with kinetic energy, okay. So what they again, when I took Hc by lambda, work function remains the same. So if I take kinetic energy as K, in the second case, when you took lambda by 2, it becomes what? 2 times Hc by lambda will be equal to the again W plus this times. This time you are going to find the maximum kinetic energy became 3 times of the first. Means it became 3 times K. Okay. So you can even, I was telling you in the synopsis that maximum you go with, you call it as substitution, or you can go with the simultaneous equation, one and the same. So you want to eliminate this, so you can just substitute for the K from here, okay? Or what you can do is you can transfer the 3 this side. If I transfer the 3 this side, it becomes what? So you can take 3 common and transfer, or you can substitute for this, one and the same. So you are going to have is 2 Hc by lambda will be equal to work function plus 3 times. For the K, I am substituting from here. K can be written as Hc by lambda minus W. So into 3, it becomes Hc by lambda minus 3 times the work function. Yeah, however you want, you can fill it. Okay, different matter. That's what I'm saying. So you can substitute, or you can go for the simultaneous equations, one and the same. Okay, so multiply this one by the 3 and eliminate. Okay, whatever you want, you can do it. So you can do like this also. You can multiply this by 3. So this becomes 3, 3 and 3K. If you subtract, so this will be gone. So you can get your answer. Okay. So everyone, you can do it. It's one and the same. Your time will be same. Okay. Consumed time will be same. So you are going to get, if you simplify this, you are going to get your option as equal to, it becomes Hc by 2 times of lambda. So third option is correct. Yes, Malesh. Spurti has joined, I think. Uh, yes, correct. Okay. Hc by 2 lambda. No problem. Next question. Light of wavelength. Light of wavelength 500 nanometer is incident on a metal with Bohr function 2.28. The de Broglie wavelength of the emitted electron is. See, our de Broglie wavelength we have is h by mv, okay, or h by square root of 2m into kinetic energy. Means anyone you have to get, either v you have to get or kinetic energy you have to get. Okay, so to get that, you need to first uh, get your ek or the v value. So to get ek or v value, so I was telling you that you can just go with the in terms of electron volt. So if this is the incident, how will you calculate in terms of electron volt? So hc by lambda is the, so I can take this in terms of angstrom and I can write as 12,400 divided by 5,000 I can write. Okay, if I write like this, so I can cut this. So this becomes the 2 point, you are going to get as 8 electron volt. Okay, so this became 2.4, you will get as 2.48 electron volt. Okay, so if you subtract this, so you are going to get the your kinetic energy. So what will be the kinetic energy you are having? You will get as 2.48 minus 2.28. That comes as 0.2 electron volt. If 0.2 electron volt is there, then what will be the potential we are having? Stopping potential I can take, potential applied I can take it as what? I can take it as 0.2 volt nearly. So if this is the case, you are having even one more formula. Since it is electron, for electron you are having it as what? 12.27 divided by, so 12.27 divided by the square root of potential. So this is one of the formula. If you substitute here, so taking root of that, you are going to get certainly, because it becomes root of this you are taking. So if I take 2 itself, you are going to get different. Since I take root, it will become certainly greater than what? This one. So do remember what you are having is this one in terms of angstrom. So but answers are in terms of meter, so accordingly you get the answer as this, but still verify, because you'll get the very closest answer, get it verified. Okay, yes, Santosh is very fast, I think. Well, so next question is a straightforward. So question is to just get the nature of graph between the de Broglie wavelength and the momentum. So since they are inversely proportional, ultimately we are expecting is the last option. Okay, next question. A certain metallic surface is illuminated with monochromatic light of wavelength lambda. The stopping potential for photoelectric current for this light is 3 times V naught. So I have taken Vs off only, they are using V naught, you can use anything. If the same surface is illuminated with light of wavelength 2 lambda, The stopping potential is V naught. The threshold wavelength for this surface, okay, for the photoelectric effect is, okay. Well, so again a simultaneous equation you have to work out. So one round you are having is Hc by lambda will be equal to Hc by lambda naught. It's similar to previous one. I can skip, I think, just I'll write the statements. Plus first round you have got stopping potential as what? When the lambda was used, it was 3V naught. So E into 3V naught I can write. In the second case, you are having is V naught. So Hc by, so understood here. Even other things you have to understand, children. See, when I increase wavelength, what happens? Energy decreases. If energy decreases, but this is going to be a constant, no? Ultimately, left out energy also decreases. So accordingly, kinetic energy decreases means stopping potential required also is less. Hc by, yes, Satvik sir, you are saying D. Yes, D is the correct option. Okay. Hc by lambda naught plus EV naught is the. So do the same thing. Either we can multiply this by the 3 and because your answer is only in terms of lambda, you can eliminate the stopping potential. One and the same. Or you substitute for EV naught from here. It's nothing but the same thing. Okay. So get it. So you are going to get lambda naught as equal to 4 times of lambda. So you are having is the fourth option correct. Well, the next question is yes, Sharon Goda is asking simple method. There is nothing like simple method, Sharon Goda. What you can do is you have to remember unnecessary formula. So I am telling you to avoid those things. Because if they ask you the things, two situations you have to take simply Hc by lambda 1 equal to work function plus the kinetic energy 1. Then again Hc by lambda 2 equal to work function plus kinetic energy 2 you have to take. Then you have to make it the equation, okay? What you use for your equation, the same thing you have to keep it as one shortcut, and again you have to remember those formulas. After all, you are having only one formula, and if you substitute in those and simplify also, it takes the same time. So my advice is avoid those shortcuts where it is of not much use, because you have to remember shortcuts only if it saves your time. Okay. Yes, you are agreeing with me. Good. So if it, because whatever you use in class, I was telling you, working in terms of nu 2 minus nu 1 and all those things, but that also will take the same time. So I was hammering you during regular discussion class, I mean, your synopsis, that here only one equation is the better remember. Only one equation, okay? So just kinetic energy we replace by EVS, that's all. Of course, we connect towards the later, maybe towards de Broglie wavelength, or as I told, towards centripetal force. Number of things may be there. But as per photoelectric effect, only one equation, okay? Well, when the energy of the incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from the metal surface increases from 0.5 electron volt to 0.8 electron volt. The work function of the metal is, so you are having is here two situations are given. So initially, if I take incident energy as h nu, so you are having it as any work function remains the same. That's what we have to find out. Plus, we are having 0.5 electron volt. Okay, this was your kinetic energy. Okay, whereas later when you increase by 20% is what I can write as 1.2 h nu. 1.2 h nu equal to again work function, but this time it has become 0.8 electron volt. 0.8 electron volt. Okay, so question is to calculate this work function. So just once again substitute for the values here. So what you are going to get if I substitute here, the work function becomes, I can just divide here, I think. So I can divide here because if I subtract, this is going to get cancelled. You can divide directly. If I divide, this becomes W plus 0.8 will be equal to 1.2 W plus half of the 1.2 is 0.6. Okay, so 0.2 W will be equal to 0.2. So we are going to get work function is equal to what? 1 electron volt. So we are having the second option. Yes, Deepak, by this time only Deepak has given answer, or Jadira also has given the answer for the same thing? No problem. Okay, where has given? Good. So you can even divide also. That's what I was telling. So it's your choice. You call it as substitution, you call it as division method you can follow. Whatever you can go for, okay? Simultaneous equation one and the same. So next question you are having is, if the kinetic energy of the particle is increased to 16 times its previous value, the percentage change in the de Broglie wavelength of the particle is. See, these are all simple questions. I think it should be in terms of percentage. There are some percentage change. Let's check it. See, we know that if this is a comparison question, we know that wavelength is inversely proportional to. Since your kinetic energy is increasing, so ultimately lambda 2 is going to be smaller than the lambda 1. So this becomes square root of, we are having is E1 by E2. So E2 is 16 times. So this becomes square root of 1 by 16, means 1 by 4 we are having. Now we can take percentage change. So make it as 1 minus on the both the side into 100. Okay, so this becomes a delta lambda by initial lambda 1 into 100 will be equal to 3 by 4 into 100. So you are having is 75, it should be percent. Okay, it changes by, yes, 75%. Raghu Patangi. Yes, I think all of you answered. Jadira also has answered. Good. Someone else, I don't know who is that. 74% is the correct answer. Let's move on to the next one. Well, this question, the wavelength lambda E of an electron and lambda P of photon it is. So here you should be careful. Photon of same energy are related by. So these wavelengths you have to relate. Okay. So lambda of E, we are having it as, so in terms of E you have to relate. So we have a new H by square root of 2me. Since you have to relate E itself, what you are having E for the your wavelength of photon, if you are writing, what will you write? Hc by lambda of photon you write, children. Okay, I think like this only we have to relate. So therefore I have to substitute for E here, or I can square and substitute. So lambda E square becomes equal to what? H square divided by 2me. Now you substitute for E here because I have to relate this. This becomes H square divided by 2m. E is nothing but Hc into lambda of photon is there. So 1 H gets cancelled. So you are going to get is H divided by 2mc into lambda of photon. So question is not to get exact value, only relation they are asking. As per this relation, it becomes what? Lambda E square is directly proportional to, we are having lambda of the photon. Oh, this time we went wrong, I think. Yes, Santosh, everyone has gone wrong. So it is supposed to be this option, third option. No one has, I think, for someone, Deepak has answered, I think. But Deepak has answered the C option, okay. Sai Prasad, not A. Yeah, not A. Because if you make A, what happens? Lambda P square proportional to lambda E. But we have got is the lambda E square proportional to lambda of photon. Lambda of electron square is proportional to lambda of photon, we have got relation. Directly proportional to, okay. So this should be the option. The same thing, they are kept reverse, okay. So third option, Sai Prasad. Still, why some of you are giving A, D and all? Santosh? No, I think I have done correctly only. If I square this, lambda E square equal to H square by 2m, it becomes, since they are again energy of electron and energy of photon, because of same energy, they again condition you just follow. Since same energy is there, I can substitute for energy, hence I squared it. If I substitute energy of photon, because we need in terms of lambda. So this is the relation you are having, okay. Shreyas, no Shreyas, I got third. Still verify yourself once where you have gone wrong, or if you feel still think, you can just explain, okay. You can just post your solution what you have done. Well, 43rd, for photoelectric emission from certain metal, the cutoff frequency, so threshold we are having is nu. If the radiation of frequency 2 nu impinges is incident on the metal surface, the maximum possible velocity of the emitted electrons will be there. Okay, so nothing is there. So we are having 2 h nu is incident because 2 nu, whereas threshold is this much means. So if you want, once I'll write the equation, W plus the half m v square is your formula, v maximum square. But nu itself here is what? 2 nu. Hence it becomes 2 h nu. This is the equation I have written. Okay, now I am substituting. Nu is this, but threshold frequency is nu means it will become h nu. Nu naught itself is, nu naught is here nu, whereas nu given here is 2 nu. Okay, just take it. Plus half m v maximum square. Okay, then you are going to get is, this becomes only one single h nu. 2 you can transfer this side, by m became your vm square. So root of this becomes your vm. So 2 h nu by m. Yes, Purti, you are correct. Why Vishwas are hurrying, I think. From where 2m came. Sharanagowda, so you are also hurrying. 2 comes this side. 2 h nu by m should be the answer, Sharanagowda. Spurti. Why Spurti you changed your answer? Or different Spurti or no, same Spurti? Removed. Fine. So next question, 44th question. Well, I think something is pending, otherwise it will be like that only. Yesterday the madam who had message, okay, she will tell madam did not solve 17th, 18th, 19th. Okay, let us complete that. 17th, 18th, 19th was pending from the yesterday's paper. So 17th one, what will be the ratio of de Broglie wavelength of proton and a particle of same energy? So actually here they are having the same energy, but a particle, when they, again, this is a wrong question actually. When they give a particular particle, Because of that, I skipped, you don't think. Just now itself, I'm also reading. So particle, when they mention, because if you use the equation lambda equal to, as your answers are clearly decided one, if they are theoretical different matter. Now decided means we cannot solve this. H by square root of 2m is there. Their energies are equal there again. What about their masses? To compare the masses, I need that particle. Maybe it may be alpha. Let us check with alpha. If it is with alpha, it may come. So we are having lambda of proton by lambda of alpha will be equal to square root of mass of alpha by mass of proton. That will come 2:1. Okay, so let us just make a correction. Let us check it as alpha particle. What are the question may be there? Yes, Satvik. Oh, you know it. I don't know. Good thing, no problem. Anyway, we assume, no problem. So, next one. What is the de Broglie wavelength of alpha particle accelerated through a potential difference? So, here my advice is, Sharan Gowda, better you remember all these values. Because with that equation, that is what you are having lambda equal to h divided by square root of 2mqv. With this, it takes out your time. Okay, oftenly any you will be remembering this. This is for your electron. This is for electron you are having. Okay, so this is for proton you are having. Remember better. So this is for your alpha particle. This is for deuteron you are having. Okay, so better remember these four values. That is my advice. And even for the neutron it comes, but whereas neutron you are going to have it as, it may come around some 30 point something you are going to get divided by square root of the temperature. Okay, what you are going to have. This is again taken in terms of course, all these are taken in terms of angstrom, because as neutron is the neutral particle, so you cannot apply this equation I was telling in the synopsis, as it's not having charge. So you have to go with the what? Lambda of neutron, you have to work with the formula as h by square root of the 3 mkt. This formula you have to use. Okay, in place of energy you are filling this 3 by 2 kt, you fill 2 got cancelled, you are going to use this formula. Okay, well, so anyway, here the answer is, so C answer. Okay, alpha particle already have written, and you two have done, I think, good. So well, the next question you are having is, the wavelength associated with an electron accelerated through a potential difference of 100 volt is. Okay, simple, because just now I said for electron we are having this as the equation. So wavelength will be equal to 12.27. They approximate sometimes. They'll give us 12.3. No problem. They'll be having distinct answers. Square root of potential. Okay, this formula is there. Here is the formula. Here is the formula you are having. Same formula we are using here. This will be equal to 12.27 divided by. Since they again 100 volt potential, okay, they are applying to accelerate it. Ultimately, that becomes 10. Just one you have to shift. So it becomes 1.227, or they made us 1.231. Yes, Sainath Reddy. Let us come back to the stream. Well, 44th question we have to continue with, I think. 44th. So, a source of light is placed at a distance of 50 centimeter from a photocell, and the stopping potential is V naught. If the distance between the light source and the photocell is made 25, so initially 50 centimeter was there, now 25 is there, the new stopping potential is, yes, Satvik has answered for this, I think. Potential difference and the stopping potential is, See, actually, both are the same because we speak as potential difference or stopping potential, keeping the emitter potential as 0. This we make compared to that a negative. So what you speak is always potential difference only. You are not speaking single potential. Okay. Yes, Sharan Goda got the hint. Spurti is answering something 4 times, we not, I think. Santosh has answered correctly. Shishada, your friend has given already a clear reason there, same metal surface. Okay, that's the right thing. See, of course, we know that intensity is inversely proportional to square of distance. On this also, you'll get your some questions. Okay, maybe I think somewhere one is there. I have included. But yes, Prajwal, okay. But question here is to work out on the stopping potential. You know that stopping potential is only depending on the what? Only depending on the kinetic energy, and kinetic energy in turn depends on the frequency of incident radiation. Okay, so for a given one surface, ultimately as the threshold frequency is not changing, unless the incident changes, this will not change. Unless this will not change, this will not change. Okay, so it is going to remain the what? Same. Sharanagoda, but not it is for the same metal surface. Okay, it's not because of same metal surface. It is because of, unless you won't change the frequency, should be your reason. Is that clear? Prajwal sir, of course, it won't depend on the distance, different matter. But Sharanagoda, you correct your things. Even though metal surface is same, even though I have the same, suppose imagine one copper surface is there, but still, when the incident radiation frequency, suppose if I change, imagine initially I have the some new frequency. If later I made it as a double new, okay, double of this frequency, then what happens? Left out kinetic energy increases. If left out kinetic energy increases, stopping potential has to increase. Okay, so your reason behind that is wrong, but whereas answer is correct, different matter. Okay, so it's going to remain the same. The reason is because only they are varying intensity, they are not changing the frequency. Unless frequency is not changed, there is no effect on the stopping potential. Okay. The de Broglie wavelength of neutrons in thermal equilibrium at temperature T. So just now I was telling something around 30 point. So you can verify those answers. Yes, Sharanagoda. No, it's good. Okay, I'm happy that all of you are analyzing yours and the things. Not of feeling bad, it's just interaction. So I'll be happy that you are interacting. Okay, if you are interacting. So right or wrong, it happens with us also sometimes, different matter. Okay, but it's better to be clear always. So I'll be happy that if almost all of you, instead of simply saying A, B, this, that, if you have worked out already in advance, just you can tell me the reason, equations, okay, something like that. Instead of simply giving B, A, okay, if sometimes we cannot do that in the mobile, different matter. If you can, just you can give those things also. At least theoreticals you can analyze, okay. A 200-watt sodium street lamp emits yellow light of wavelength 0.6 micrometer. Assuming it to be 25% efficient in converting electrical energy to light, the number of photons of yellow light per second. Well, already we have done a formula for number of photons per second. Okay, so what was our formula? It's nothing but we have it as power by energy of each photon, right? Because power equal to is what? is nothing but E total incident by, if I take per second. So E total incident becomes what? E total will be equal to, we have it as the per second is nothing but it becomes the power. But whereas we want is the number of photons, how will you find? By dividing by the energy of each photon. So when I divide this by each photon, then this also should be divided by the what? Each photon. So I am taking per second this side. So which has to come here. So I have taken this side. So power is given to you already, but it's only 25% there again. So make here itself 25%. So 0.25 into 200, or you can write directly if you are fast enough, that becomes 50 watt. Okay. So into, sorry, nothing into, divided by energy of each photon. So let us go with that values. Hc by lambda I have to fill. So fill it. 0.25, this became near 50, into lambda given is 0.6 into 10 to the power of minus 6 divided by h value we are having 6.6 into 10 to the power of minus 34 into 3 into 10 to the power of 8. Okay, so check it approximately how much it can come. So this is nearly 1.1, leave it and it's 1, like, so this is going to be around 16 point something. So already if it's 16, everything is cancelled. 16 point something nearby means you can expect the first option, I think. 1.5 to 10 to the power of 20 should be your answer. Okay. Well, yes, Ashwini, Sai Prasad, Abhi, Baswaraj, yes, all of you again, Raghu, correct answer. Okay, first option, Aishwarya. So next question is, monochromatic radiation emitted when electron or hydrogen atom jumps from first excited. Read the question. Try this. If you are tried, tell me in wordings that how you are linking. First of all, you tell me what is meant by first excited state. First excited state means what? N equal to 1. Sachin, first excited state means what? Again, monochromatic radiation emitted where electron, it should be in hydrogen atom jumps from first excited state to ground state. Then ground state what? N equal to 0, I'll call. Who has answered? Yeah, now someone is, Jadira is answering, correct. Not second excited state. It is not second excited state. We call it as first excited state itself. First excited state means electron which is in the ground state. Your ground state itself is first orbit. Okay. So electron here has to move to the second orbit. This is called as first excited state. Of course, these things, when I say first, I'm saying just because nothing is mentioned, no series is mentioned. Otherwise, actually, these will change. Let me make it clear. It depends on what series you are discussing. Yes, yes, Arun Kumar, correct. But listen carefully, all of you, those who answered 2 or 1. It is not necessary to be only this is the first excited state. Right now, this is first excited state. In this question, this is first excited state because they have not mentioned particular series. Hope you remember that you have learnt Lyman series, Balmer series like that. So this is the first excited state in the Lyman series. Since nothing is given, I just go with the what clearly there again from first excited state to ground state. So I'll take it as 2 to 1 directly, okay? But whereas if it is belonging to the Balmer series, because your Balmer series is nothing but starting with the second orbit, okay? Lower orbit is second. So higher can be anything up to infinity. When I say there, n equal to 3, n equal to 4. When it comes to the Balmer series, if I say first line, first excited state and all, so that can be anything. So this is your first excited state. So this becomes your second excited state there. Whereas if it is falling from the n equal to 3 to n equal to 1, that becomes the first line. Okay, first line in the Balmer series. So this becomes second line in the Balmer series. Okay, the things will change. Things will change, okay, depending on the series there what you are going to learn later. But right now it's nothing but n equal to 2 to n equal to 1, okay, n equal to 2 to n equal to 1. Further, what will you do? Yes, Arun Kumar sir. C is the option you are giving directly. Calculate already. Good thing. No problem. Okay, let us continue. Otherwise, we'll be running out of time. Some at least few JW questions also to be discussed. See, the stopping potential is measured to be this much, they are saying. So threshold frequency of the material they are asking means I should know first for that what is the emitted energy I should know. Okay. So let me come back. N equal to 1. This is your ground state. And first excited state, which is nothing but N equal to 2. Means an electron is now getting transited from the what? Second orbit to the first orbit. So during that you are going to get is a photon is emitted. So can you tell me what will be its energy? What will be its energy? What is the energy in the first orbit you are having? Minus 13.6 electron volt. Hope you remember the children. Whereas here we are having is minus 3.4 electron volt. Okay, very good, Satvik. Okay, so you are going to get the difference of this as per your Bohr's postulate. So you have got the energies. This minus this should do E2 minus E1. So that becomes plus emitted energy is plus 10.2 electron volt. Very good. Okay, Satvik. So yes, Prajwal. So 10.2. So emitted is 10.2 minus already given the stopping potential is this means EVS I can do. This itself if I write into electron that becomes equal to your kinetic energy. So minus 3.5 electron volt. Okay. So this becomes equal to you are having is I think just one less I should do here. So 10.2 minus 3.5 you are going to get is the if I transfer here, so 10 minus 6 we are having is 10 minus 4 6.7. okay, so 6.7 I got. Okay, 6.7 electron volt I got the what? The work function, but you need to calculate is threshold frequency. Hence h nu is this much. H nu naught we got as 6.7 electron volt. You can multiply with 1.6 into, because data is in terms of SI, into 10 to the power of minus 19, and you want nu naught by h you do 6.6 into 10 to the power of minus 34. So design data is that this a small difference you can neglect as clearly understood 1.6 mode of checking power if you are correct. Okay, So your option should be what? The third one. Okay, your option should be third one. Hope it's clear. See, like this we can link anywhere I was telling. Now you are linking with your atom syllabus. Good. Those who have tried in a right way, very good. So next something is missing. Only unit is missing, I hope. So next you are having is an alpha particle moves in a circular path of radius 0.83 centimeter in the presence of a magnetic field of 0.25 Weber per meter square. The de Broglie wavelength associated with the particle is. Okay, no problem. So you are having is R equal to Q, mv by QB is the mv by qb is the, so mv I can write as what? This is a momentum I can write. So momentum divided by I can make qb. Okay, we got, I think, because radius is available. Hope you got, children. So p I can write as what? Further r equal to, we can write this as, because since you want wavelength, I can write as h by lambda into qb. Now we make for lambda equation and substitute all the things. H divided by, it becomes QBR. So 6.6 into 10 to the power of minus 34 divided by its alpha particle. Charge will be 2 times E, equivalent to helium nucleus. Remember, it's 2E, children, okay? So 2 into 1.6. Yes, some of you are answering already. Very good, Deepak. Yes. Arun Kumar, correct. Very good. So you are trying to give the equation. So 1.6 into 10 to the power of minus 19, field is given as 0.25 Weber. Radius is given as converted 0.83 into 10 to the power of minus 2. Simplify all this, you are going to get nearly, you may get, I think, because some data are not going to get completely cancelled. So fourth should be the, I think it should be angstrom, because so much power is left out. Angstrom, okay, unit is missing there. Angstrom, hope it is there in the posted paper. So next question is, photoelectric emission occurs only when the incident light has more than a certain minimum. Yes, what is the answer? Thank you, Suleiman. When children are nice, teachers will be automatically nice, okay? Yeah, fourth one answering. So my question is now, why not speaking in terms of second? What is that? What is the hint in the question? Yeah, Siddharaj Ali or whoever has answered, all of you. Yeah, Santosh, Abhi, everyone correct. But okay, Shivarai, my question is, Spurti, madam, anybody can answer me. Why is frequency? Why don't you? Because while defining the threshold photoelectric effect, we define with both the condition. Wavelength condition, Seema is changing her answer now because I'm asking why not wavelength. I asked hint in the question, Seema, not to change your answer. Yeah, very good, Rashmi. Okay, because question is more than. Okay, that is the hint. Otherwise, we speak in terms of the maximum wavelength, minimum frequency. Question is, incident light has more than a certain minimum. So minimum this much should be there, more than this, then only the photoelectric effect is going to occur. Because if I make more than wavelength, more than this minimum wavelength, then the energy decreases. Okay, very good, Satvik. Okay, all of you are answering now. So I have to go in. So condition is there. Otherwise, we speak in terms of both threshold wavelength and threshold frequency. But since they are given more than a certain minimum, so that makes it make us to go to the fourth option. Okay. Yes, Raghu, correct. Less that. Well, the next question is light of two different frequencies whose photons have the energy 1 electron volt and 2.5 electron volt respectively illuminate a metallic surface whose work function is 0.5. The ratio of maximum speeds is. So this can be because we have the equation as half m square equal to h nu minus h nu naught, or directly work function, because again this already work function. So anyway, when I go with this will cancel directly, I can write as V1 by V2. Initially you are having 1 electron volt and your threshold, okay, I mean sorry, work function is what? Our threshold energy is this much. So 1 minus this became what? 0.5. In the second case, work function remains the same, but you are making two incident 2.5. So 2.5 minus 0.5 is what? 2 is there. So that makes 1 is to 4. So we have the first option as the correct one. Hope I have done correctly. So sorry. This is square is there, na? This is square is there. I made that mistake because option is given as second one, and all of you are, some of you are already answering. No sign authority. You two did the same mistake like me, I think. Yeah, under root spurti. So V1 by V2 it becomes 1 is to 2. Okay. Well, the next question is electrons used in an electron microscope are accelerated by a voltage of 25 kilovolt. If the voltage is increased to 100 kilovolt, then the de Broglie wavelength associated with the electrons will be. See, we know that wavelength is inversely proportional to square root of potential difference applied. Okay. So lambda 2 by lambda 1 becomes what? Square root of V1 by V2. So what they are saying is change to 100. So fill just directly the value. So 25 by 100 is there. That became 1 by 4 means 1 is to 2. So lambda 2 became what? Lambda 1 by 2. So if you make it 4 times, this is going to decrease by 2 times. Okay. It becomes decrease by 2 times. Yes, second is the correct answer. Suman. Well, the next question. In photoelectric emission process from a metal of work function this much, the kinetic energy of most energetic electrons is found to be this. Okay, nothing is the direct question. You know all of you very well. Okay, I thought by this time some of you have answered. Rashmi answered. Okay, fine. Because this is the kinetic energy. Remove the E, that becomes your stopping potential. Okay. No Jayashri, not second. Not Jayashri. Jayalakshmi, I think. A beam of cathode rays is subjected to crossed electric and magnetic fields. The fields, so again we are linking with some other syllabus. The fields are adjusted such that the beam is not deflected. Where you have learned this one, in the velocity select in your magnetic effect of electric current. Means where the force experienced by the magnetic field was supposed to be equal to force experienced due to the electric field if they are crossed fields and adjusted to such values. It goes undeviated. Velocity select we call. In that case, you are not deflected means what? It goes undeviated. So what you are having this one as QVB because in your perpendicular. So this is QE is there. Q cancels. So your V was equal to E by B. Okay, E by B. So what is the question? So the specific charge of the cathode rays is given by. They are asking further. What is the specific charge of cathode rays is? Okay. So how will you get it? How will you get it? Because the answers are in terms of potential. Okay. Potential. So understood. I have to link velocity in terms of the potential. So what we are having? Half mv square equal to, you are having EVS. Right now let me write VS, otherwise V and V may get confused. So therefore V square became what? Or V became what? V becomes square root of, you are going to have cathode rays means beam of electrons. Okay, so E I have taken. So it becomes 2 EVS divided by the M. Just substitute here and finalize your answer. So this becomes square root of, I'll square it both the side better. If I square, because you have to get it charged by mass ratio, I have to square in here. So this becomes 2 EVS divided by M will be equal to E square by B square. I want is only this much. If you want only this much, then E by M. We got a specific charge, children. Hope you remember. Specific charge of any particle is nothing but we have it as charge of that particle by the mass of that. Whereas we are speaking of cathode rays, hence electrons I am taking, will be equal to, you are having is the E square divided by 2V into V square. Vs, the again as V. Okay. So we are not getting, we are getting the fourth option. Someone had given already as the second, I think, check it, we did correctly. Yes, the D option, Deepak, correct, okay. So fourth is correct, na? Someone had given before second, I think, no problem. Well, the next question. Yeah, Sumant sir had given, I think, no problem. It happens in hurry. A source S1 is producing 10 to the power of 15 photons per second of wavelength 5000 angstrom, and the source S2 is producing this much photons per second. Then S1 by S2 they are asking. See, already I had given number of photons per second. Okay, per second. We had the formula as the power divided by energy of each photon. Okay, each photon we had. Okay, they are given already. Per second of this much wavelength. Wavelengths are given to you. Wavelengths are given to you. So further I can write as, so N1 per second I can write as equal to P1 or S1, what they are called. Okay, so P1 divided by this becomes Hc by lambda 1, whereas N2 per second will be equal to P2 divided by Hc by lambda 2. Okay, just you can divide these two equations to get the P1 by P2, children. So if you divide, I think you are going to get the answer as the first one. Just check it. N1, N2, because closest one, I think you can get it. If not, just verify. Ishwara has given already. Yes, correct. Okay, thank you, Sharon. Go down. So first one is the option. Okay. Next question, the potential difference that must be applied to stop the fastest photoelectrons emitted by a nickel surface having work function 5.01 electron volt when ultraviolet light of 200 nanometer falls on it must be. Okay. Okay, so straightforward question is that just get first your Hc by lambda will be equal to work function is already given plus EVS, because to stop they are asking EVS you can do. This is, you can take it as 12,400 divided by 2000 you can take. So 12.4 means it becomes 6.2. This is given as 5.01 will be equal to EVS is the, therefore EVS becomes equal to 6.2 minus 1.0. 5.0 means it will become 1.19, I think. So 1.19 we can take nearly equal to what? Nearly equal to 1.2 we can consider. Okay. So last one here they're asking stopping potential. Okay. So ultimately you should not go with the minus, you have to go with plus. Rashmi has answered second. So make a correction, Rashmi, Sainath, Deepak. Okay. So deviation now they are done correctly. Okay. So be careful when they ask only stopping potential, they're asking magnitude. So you have to go with the positive values. When they ask clear, like in one of the question was there, relative to the emitter, okay, electrode, then you have to go with negative answer. Next question. If a source of power, sorry, if a source of power 4 kilowatt it should be, produces 10 to the power of 20 photons per second, the radiation belongs to a part of spectrum called. Well, from the same relation, you have to find first number of photons per second. Just know what we had is equal to power there again divided by hc by lambda was there, right? So from this you get first lambda, children. Okay, so get the lambda, but this question requires again your memory based question. It is, even though not, I cannot say it as simply memory based also, knowledge based also, because after first you have to solve it. After solving you should remember what are the wavelength ranges of all these. That's what is done in the electromagnetic waves. So they are linking this syllabus as well as your photon knowledge as well as the electromagnetic waves. Okay. So there, for at least even both theory wise, also you have to remember the ranges of all the electromagnetic radiations from microwaves to your gamma rays. So after finding this value, you have to decide. So decide yourself. I'll leave it to you. That which option comes, you can just check it. Okay, using this formula, first find the lambda value, then you can verify. Basaraj is telling 4. Let us check it. Okay, so solve it. Okay, Malish is telling C. First you calculate whichever is coming, you finalize yourself. I am leaving it to you, children, because I have not marked it. Photon of frequency nu has a momentum associated with it. If c is the velocity of radiation, then the momentum is. It's a straightforward question. Is there? You are having it as momentum of that becomes what? Photon. We are having it as h nu by c. Yes, Sachin. So next question you are having is. Well, so from last question onwards, you are having almost your some JW questions also level. Doesn't mean that it won't come for me. It means they are taken from the JW old question papers. The time taken by, this is knowledge based, time taken by the photoelectron to come out. So I was telling that when a photon is incident, if it is interacting with any valence electron, okay, or what you call it as a free electron, then to make this free from the surface, or what you call it as photoelectric effect to take place, so it takes around 10 to the power of minus 10 seconds. Remember this, I think I did not tell in the synopsis. Do remember, this is supposed to be remembered. Okay, memory based. So next question. Sodium and copper have work function 2.3 electron volt and 4.5 electron volt respectively, then the ratio of their threshold wavelengths are nearly. So just you have to make it as inverse of them, because threshold wavelength means hc by lambda not. So already work functions are given. So this becomes inversely. Just you can have it as lambda of copper by lambda of sodium by lambda of copper will be equal to work function of copper by work function of the sodium. So work function of copper they are given as 4.5 by 2.3. So 2.3 2 you are having 4.6, almost nearly 2 it comes. So nearly we can go with this 2:1. Okay. Yeah. Here you have the question. Okay. What? Some of you are getting confused and answering before. A photo cell is illuminated by a small bright source placed 1 meter away. When the same source of light is placed zero point 0.5 meter away, the number of electrons. We know that the intensity of light and the current. This, if I take it as current and the intensity of light, they are directly proportional. And but whereas the number of photons, okay, what you are having, so is going to be intensity is given as inversely proportional to square of distance. So intensity, because question is in terms of distance variation, so later you can think of current, okay, if it all required. So intensity varies inversely as the square of distance. Since you are going to make it half, okay, you are going to make it half, so half square becomes what? 4. So it becomes 4 times, it is going to increase. You are decreasing the distance, whereas it is increasing by 4 times. So second one should be your option. Okay. Why Raghu sir deleted? No problem. Rashmi is correct. Okay. Second option. Next question. According to Einstein's photoelectric equation, the plot of kinetic energy of emitted electrons from a metal. So some theoretical questions also are added. See, even in your JW mains also you have some theoretical questions. Okay. The plot of kinetic energy of the, so we had got as, if you take kinetic energy versus the frequency. So we had mathematically this as what? Kinetic energy was equal to h nu minus work function. So this intercept was giving us directly the work function, whereas this slope was giving us the h value. Okay. So when it is a h value, it's a constant. So where is a constant, it's going to be same for all the metals and independent of intensity of any radiation should be your answer. Okay. Because first one there again depends on metal. H will not depend on that. Depend on intensity, they again wrong. Depends on both, they again wrong. So ultimately we have to go with the last option. Very good. So many of you answered before I speak. Well, next question. See, in your JW mains, simply they have made something. The moment they see equation, they should think there's something hi-fi. Nothing is there, because this question before also we had done. Two identical photocathodes receive light of frequency F1 and F2 if the velocity of photoelectrons coming out are respectively nu1 and nu2. Then, so just you have to relate this. Sorry, velocities are to v1 and v2 respectively. Okay, so we know that half m v1 square will be equal to what? So we can write as h. They have written f1. So let me write the same thing. F1 minus work function. Similarly, half m v2 square, I can write as h f2 minus work function. Okay. So suppose if I'm going to subtract these two, because that's what they have done, nothing else. So v1 square minus v2 square into half m by 2 I can take common. This becomes h common, f1 minus f2. Yes, A is the answer. Okay, very good. So v1 square minus v2 square becomes what? 2h by m into f1 minus f2. Just two equations, two situations, they are subtracted. Okay, so first one is the correct option what you are having. Okay. Next one. The surface of a metal is illuminated with light of 400 nanometer. The kinetic energy of the ejected photoelectrons was found to be this much. The work function. So hope this you can do yourself, children, because this type of questions already we have done with. Verify. They again the option is the second one. Yes, Satvik sir. Second one there again. Verify yourself. Just we can skip that. Next one. A radiation of energy E falls normally on a perfectly reflecting. So it's a perfectly reflecting. I said already in JW and all, they take you towards all such things. Linking is bit more, okay, on this syllabus. Linking will be there in the NEET of if you take in different syllabus, but in this usually we can expect in the 1.38 approximately. Okay, no problem, you are speaking, I think of before. Falls normally on a perfectly reflecting surface, the momentum transferred is. We know that already momentum of photon we are having is what? E divided by C. But they again perfectly reflecting means what happens? So P final minus P initial I should do. So when this is a surface, incident is again a reflecting back. This becomes what? Minus P. This becomes plus P. So we are going to have is minus P minus P. That will become minus 2P. Okay. So twice I have to get. So only they are given magnitude here. So 2 times it becomes E by C. So we are having is the second option. Okay. Well, let me stop, I think, because your last one will have other answers. I'll just post it by using children. Now let me solve and post it. So still, if you are having any queries, you can ask once I post all the answers. Okay. So because your next teacher is waiting there. The de Broglie wavelength of a tennis ball is given to this, given as 60 gram, and its velocity is given. So it's a straightforward question. We are having for any matter in motion, it is supposed to be it is supposed to be what? It is supposed to be h by m. We can apply for any matter. So we are going to have is, if you substitute this and you can verify your answer. So after substituting, you are going to get it as the check your answer. I think I'm not getting where maybe 10 to power of minus 30. Yes, already some of our friends are giving. Raghu is there, Divesh 5. So you are going to get is the first option. Okay, so verify it yourself. Okay, Sachin, thank you for struggling to type it. Okay, well, children, thank you for joining. Again, I'm saying that remaining solutions I'll just post it by uni. You can verify those things. Still, if you are having any doubts, you can get it clear. Wish you all a very, very happy Diwali. Enjoy your Diwali. Hope we meet soon, because without children, it's very difficult to enjoy the classes. Okay. Thank you. Thank you for joining. Good day. Happy Diwali once again.